Okay, welcome again. So we'll continue our lessons. In our previous lecture, we started at 11. In this unit, we started our first lesson, and it was about vessels of valves. In this lesson, we'll talk about switches and relays. Okay, before going through these exercises, we'll try to understand the meaning of switches and relays. Okay, switches is basically a tool or a device that is used to turn on or cut off the current from an electrical circuit. Okay, basically, you can use a switch to turn off an electrical current and turn on electrical also from the current. Okay. Relays basically have similar meaning of switches, but the difference between switches you manually control by turning on or turning off the electrical source. Okay. As for relay, okay, you don't need to manually control it. Okay, it will automatically gonna turn off the electrical current from the electrical circuit. So this is the main difference. An example for a switch is when you want to turn on or turn off the lights. Okay, you manually press the button on so you can turn on the lights. As for relays, you can't do that. It will automatically turn off if there is some dangers, for example. Okay, see number 1. In this exercise, we'll go through these symbols and try to identify their meanings. Okay, these symbols can be found in the electrical circuit. Okay, the electrical circuit is like a plan that describes how device could utilize the electrical source. Okay, these are the vocabulary, and here we need to match them. Okay, at the beginning, so we have battery, bell, buzzer, conductor, earth, lamp, switch, terminal. Okay, we'll try now to match each one of these with this vocabulary. Okay, the first one is the conductor. So this is the conductor. Okay, it works as an insulator that prevents, not insulator, it connects the electricity one point to another. Okay, if you want to transfer the electricity, you need a conductor. An example of a conductor is the wire. Okay, so this is the lamp. If your device contains a lamp, then this is how you should write the electrical circuit. Okay, this is a buzzer. This is a bell. Okay, it makes sound. Bell, it makes sound. This is the earth. Okay, what do you mean by that? If you want to transfer what is high of an electrical power source, okay, you need some sort of earth so that cause a fire, for instance, in the place. Okay, so you have high voltage, higher, but to prevent the shortage of electricity, you need this device to prevent from electrical shock or not getting the device to work properly. Okay, this is the switch. As you can see, the switch is turned off Now there is no electrical current because you switch the current off. Okay, if you switch it on, then it will connect it and become as a conductor. Okay, this is the terminal, and finally we have the battery. Okay, for example, a simple electrical current will contains battery. Okay, battery is the source of electricity. You need a conductor to carry over, right, to carry the current from the battery using the conductor. And then you need something that utilize from this electricity, for example, lamp. In order to turn on the lamp, you need a battery conductor. So battery transfer electricity through conductor, then it will go to the lamp and then it will shine light. You also need a switch where you can turn off or turn on the electrical power. So these are the an example of electrical symbol that we see in you want to draw electrical circuit. Okay, look at number 2. Listen and name the sounds. Choose from the list below. So each sound, each vocabulary from here represent the sound. For example, click. This is if you used your mouse, the sound it produces is called click. Okay. Also, it works as a verb. Whenever I tell you to click on something, okay, but use the mouse to do so. Okay, we'll at the beginning we'll hear, and then we'll try to match the sound with the hearing. So most of them you will understand the meaning based on the sound. Okay, because if I click, the sound is represented by its name, click. Okay, these are the words: buzzer, doorbell, click, siren, horn, beep, alarm bell, dial, tone.
Unit 11. Cause and effect. Recording 56. 1. Two. 3. 4. 5. 6. 7. 8.
Okay, I will try to go through this vocabulary. Okay, the first one was the alarm bell. Second one was beep. Third one was the buzzer. Horn was 4. Dial tone. If you will call somebody else, you need the tone you hear is the dial tone. Okay, doorbell. If you want to visit someone else, instead of knocking the door, you click just on the bell. The sound that is produced is the doorbell. Click. You use a mouse. And finally, siren. Okay. We'll go through the listening again.
Unit 11. Cause and effect. Recording 56. 1. 2, 3, 4, 5, 6, 7, 8, 'Unit
Okay, for 3, we have reading. We need to know how does this window burglar alarm work. Burglar means that you can see, okay, a thief who enters forcibly to a home without an invitation to steal something. Okay, as you can see, this thief tries to break through this home by breaking the glass, and then he wanted to open the door. So we have a system that would prevent the thief from entering the house. Okay, it is called burglar alarm. Okay, window burglar alarm. Alarm basically a device where it produces sound to alert those who are um, nearby, to intervene to stop this criminal from entering the house. Okay, the alarm basically it produces sound, noise, so everyone who is living nearby should be aware that there was a criminal who wants to enter their house, for instance. So, and so this is a web page. You need to label a circuit diagram and the diagram in 3. Okay, this is the diagram. It shows a picture of something that is not a real picture. It's like a drawing that describes or represents a device. Okay, we are talking about the burglar alarms. Okay. So we need to both these words. Okay, we have battery, buzzer, spring, switch, terminal, wire. We need to put them, match them in this picture or this diagram. Okay, in order to do so, we need to read. Okay, before going through these, because through reading we could understand how this device works. Okay, ask Mario. Our electrical expert, Mario, answers all your questions. Hi, Mario. He names Bob. How does this burglar alarm on my window work? So this is the specialist, which we need to receive the answer on how this device works. Okay, well, Bob, on your window there is a small magnet. Okay, next to it, on the window frame, it looks like that, window frame, there is a metal switch to terminals. Okay, terminals are attached to wires, and the wires are connected to a battery and a buzzer. Okay, they make a simple circuit. When the window is closed, the switch is next to the magnet. The magnet pulls the switch towards it. This closes the circuit and electricity flows through it. The buzzer doesn't sound. When the burglar opens, so we are talking about the thief, the criminal, opens the window, he breaks the circuit. The magnet moves away from the switch, and this allows the spring to pull the switch back. This opens the circuit. The open circuit prevents the current, means stop to avoid current from flowing. this happens, the buzzer makes a sound. So it only works if there is breaking into the windows. Okay, so we need to match these vocabularies. So the first one, okay, for number one is switch. Okay, this is the switch. Number two, the spring. For number three, the terminal. For four, the buzzer. Five is the battery. And finally, Y, which is the conductor. Those are the components of the burglar alarm system. Okay, we have another reading. We need to read and then provide answers in exercise 7. So we need to answer how many circuits are there, how many electrical magnets are there, what is an electrical magnet, how many switches. So we are here asking about numbers, basically, from 1 to 3. We need numbers, different items. Finally, what makes a switch open and close? We need just an explanation to be provided so we understand how this system works, when to be opened and when to be closed. Okay, read the next part of this web page, check your answers to 5. Okay, because there is another circuit, the buzzer has its own circuit. When the window circuit opens, this makes the buzzer circuit close. How does it happen? The buzzer circuit has its own battery, an electrical magnet, and a relay switch. This is how it works. When the circuit is open, this causes electrical magnet in the window to switch off. The electrical magnet releases the relay switch on the buzzer circuit. This allows the spring to push the switch. The buzzer circuit closes. The current flows from the battery around the buzzer circuit. This makes the buzzer produce a loud noise. Okay, I understand the circuit, but how does the buzzer make a sound? That's easy. Here's what happens. The current flows through the buzzer circuit. The current makes the electrical magnet switch on. 3. The electrical magnet pulls a metal strip away from the thin wire. This causes the current to switch off again. When the current switches off, the electromagnet switches off. This allows the metal strip to swing back toward the thin wire. 7. The metal strip moves quickly up and down. This makes the loud buzzing sound. Okay, let's try to answer the questions. For the first one, the number of circuits, we have 2. What are they? The window circuit and the buzzer circuit. Okay, the buzzer circuit is the one responsible in producing the sound that alarmed those who live nearby. For number 2, how many electromagnets are there? So we have 2 types of question, 2 sections. This is the first section, and then the last section, the definition of electromagnet. Okay, how many? So we have 1. Okay, the definition: electromagnet is an iron bar with a coil of wire around it. It is magnetic when the current flows in the coil. Okay. Magnet means that it can be automatically operated. Okay, so it's magnetic. For 3, how many switches are there? We have 2. Finding when I say switch open and close, the current. Okay, so the current responsible on opening the switch and closing it off. Okay, for 8, we need to complete the sentences with the correct form of the verb in the box. So we have these verbs. We need to put them in the correct blank. As we said before, each one represents use. For example, cause, okay, is used if the subject is not the doer of the action, okay? What was responsible or what the reason for the object to have an action. It requires the preposition to. Allow is used if you want to give a permission or a device or tool to give permission to another tool. Okay, let is similar to allow. Make, basically to force someone. Prevent and stop means avoid. If you want to use both of them, it has you have to put the preposition from, and after that you should add on the verb ing. Okay, so you need to put the suffix ing in the verb. Just try to answer 1 up to 6. Okay, first one, the electromagnet switch on the way on the contact. So we need some that wire to from here. We should put reference because it's from. You need that verb and load with ing. Next, force it to switch away from the magnet. Answer to go through the rest of the sentence. Try to identify the and what happened to the verb. As you can clearly see, preposition from and we added. Now there is ing on the verb. So the answer must be either prevent or stop. Both of them are correct. And before that, we need to also to focus on the subject of the sentence. If it was singular, we basically needed to put s on the verb, as we did here and here. 3, the wires, so this is plural. The electrical current, 2, so we have 2. So from the battery to electromagnet. Allow, okay, allow. So here I just the wires has given permission for the electrical current to flow. So I basically give them permission. The wire wasn't the cause for the electrical current to flow. Okay. 4, the open switch. Okay, for understanding this sentence, as you can clearly see, we have from and ing in the verb. So one of them would be the correct one. And for attempting also to answer, you look at the subject, there is no S, so in either one of these, you need to put S on them. So both of them is correct, okay, including S, the suffix is S. 5, the spring, the window switch 2. Okay, the answer here is causes, because the spring was the reason responsible for the window switch to be broken. And also, causes comes with 2. Okay, you cannot use cause without the preposition 2. For 6, the closed switch, the current flow around the buzzer circuit. Let's okay, here the closed switch has given the permission for the current flow around the buzzer circuit. Okay, so these are the answers for exercise 8. Okay, now we're gonna go to exercise 3, or lesson 3. It will be about rotors and turbines. The exercise 3 will be about rotors and turbines. Okay, rotors is a piece of device that rotates in order to produce a force or power. For example, part of a device or vehicle that is responsible on transferring the main device is rotors that can be seen on helicopters. So the helicopters cannot be flying without utilizing rotors. So rotors produce the source of power that help aids the helicopter to go up and fly. Turbines are basically a device that has rotor. Okay, so the turbine, its main function is to produce power source like electricity. We can find turbines in some modern countries that would rely on the wind source. So it will take the wind source to produce electrical current for a village, for instance. So these are rotors and turbines. We'll take their pictures and our upcoming exercise. Okay, exercise 1, we have a quiz. Quiz is a short exam that consists of short questions. Okay, you can see we have from 1 to 4. Each question has choices to choose one. One of them is correct. Okay, so we need to answer how tall, how high, and what is the minimum and maximum wind speed. So we have different questions. In order to be able to answer, we need to rely on the listening. Of course, you can guess on your general knowledge about this topic, but I think since most of us are not specialized in this area, they will basically rely on the listening. Or you can just simply stop the video and try to answer, or attempt to answer before going to the listening again. Okay? Okay, let's try to hear and try to choose the correct one.
Unit 11. Recording 57.
The German company Enercon manufactures the world's tallest wind turbine. The tower of this huge turbine, the Enercon E112, is 186 meters tall. But the world's highest wind turbine is about 2,300 meters up a mountain.
Unit 11. Recording 57.
But the world's highest wind turbine is about 2,300 meters up a mountain in Gutsch, in Switzerland. The tower of the wind turbine isn't very tall, but at 2,322 meters, it's the highest in the world. Wind turbines start producing power at the minimum wind speed of about 15 kilometers per hour. If the wind speed is less than 15 kilometers per hour, the wind turbine doesn't switch on. The maximum wind speed for a turbine is about 90 kilometers per hour. If the speed of the wind is more than this, the turbine switches off and the blades stop.
Okay, for the first one, the tallest, the tower of the world's tallest wind turbine is 180 meters. The world's highest turbine is, who has about 2,300 meter high. Number 3, the minimum wind speed for the large wind turbine is about 15 kilometers per hour. The maximum wind speed for a large wind turbine is about 90 kilometers per hour. Okay, for 3, we need to label the diagram. As we already talked about, the diagram is a picture that illustrates how a device works and contains a description of their internal parts. So this is a diagram. It is not a real picture, but it is a drawn one. Talk about this device. So we are talking about the turbine, and we go through its main component. And by going through this vocabulary, this component, we will have a general idea about how these devices work to generate power. So these are the items that we need to match in this diagram. So we have from 1 up to 8. So we have plate, brake, gear, generator, housing, hub, shaft. Okay, let's take one by one. Okay. Okay, of course, you need to rely on the reading before attempting to answer this diagram. We'll go through this reading. The wind turbine consists of a tower, a rotor, and housing. This is the rotor. This is the title of the lesson. It was about rotor. This is the rotor, a part that generates force by rotating. So this vehicle or this helicopter goes up. And also it can be used in the turbine, so it would reduce power relying on the wind sources. The rotor consists of 3 plates. So this is plate. Okay, a plate, it's one part that can be seen in the rotor. And the hub. The housing is a strong, rigid container. It contains a low-speed shaft, a high-speed shaft. Okay, 2 gears, a generator, a controller, and a brake. The low-speed shaft connects the rotor to the gears. The high-speed shaft connects the gears to the generator. So the housing at the back, behind the generator, is the controller. Okay, the first one, shaft. So low speed, this is the shaft. As you can see, is the metal, a long metal. This is the shaft. For number 2, this is called gear. So this is gear. So in this device, we have 2 main gears. For 3, so this is the housing. It's like a body that contains the internal part of the turbine. For 4, this is the generator. Okay, the generator would absorb the power of the turbine, so it will produce energy. For 5, also we have, and you can see here, high speed. Okay, high speed shaft. So we have shaft here for high speed and for another one for low speed. Okay, 6. For 6, this is the brake. Okay, as the name entails, brakes would stop the turbine from rotating, the rotor from rotating. 7. Okay, this is the hub. Now this part is the hub. Finally, 8. So we have 3 plates. So these are the plates. Okay, and you can see every part of this device now is essential to enable this device to function properly. So this is the tower. So we have tower, rotor, and a housing. These are the external parts of the turbine. Okay, for 5, we need to read the web page and the question below. So we have a question for 1 to 3. Questions ask about, for first one, you need to know which part makes the low speed shaft turn. Number 2, what are the 2 main functions of the controller? Or 3, which part transmits rotation to the generator? Okay, yesterday, Techno Challenge interviewed the wind turbine expert who had a lot of years of experience, either a formal one, like he's went through a college to understand turbine expert, turbine knowledge, or through experience as working as turbine engineer. So this is the meaning of expert. Dr. Roger Jones. Here's part of the script. To download the whole script, click here. How does the wind turbine work? Okay, the wind blows on the blades and makes them rotate. Okay, so it relies on the wind. So it would be able to be rotated. This causes the shaft to rotate at a speed of about 30 up to 60 RPM. Isn't that too slow? The shaft in a generator must rotate at about 1,200 and 1,400 RPM. That's right. There are 2 shafts. There's a low speed shaft and a high speed shaft. Low speed one is attached to a large gear. The high speed one is attached to a small gear. The large gear makes the small gear turn. The small gear makes the high speed shaft rotate. This shaft rotates at 1,200 and 1,400 RPM. I see, and it drives the generator at this speed. That's right, and then the generator produces AC electricity. What happens if the wind is too strong? The anemometer measures the speed. So the tool that is used to measure the speed of the wind is called the anemometer. It sends this data. Data is a sort of information about the speed of the wind to the controller. The controller is a small computer, so the computer measures and provides control to either to stop or proceed the speed of the turbine. If the speed of the wind is more than about 90 km, the controller automatically switches off the wind turbine. This prevents the wind from damaging the turbine. But the purpose is to prevent, to avoid the turbine to be damaged. Okay, this is the whole purpose. So at certain height, certain speed of wind, the turbine should be switched off. Otherwise, it will cause some damage to it. Okay, the first one, what part makes the low speed shaft turn? The large gear. Okay, this is the large gear. What are the 2 main functions of the controller? Okay, the controller collects data about the wind speed, also prevents the wind from damaging the turbine by switching off the turbine. Because this is the purpose of the controller, as you can see here. Or say which part transmits rotation to the generator? The high-speed shaft. Okay. For 6, we need to identify which what do these words refer to. Okay. For example, the first one is used if you want to replace something, or to substitute a noun. For example, if I came to you with 2 pens, I don't need to just repeatedly say which one, for example, do you want? The red pen or the blue one? Okay. Basically, I would replace the word pen with one. So I came to you, asking you to choose one. Okay. So instead of saying the word pen, I would replace it with one. Would understand what do I mean by one. It replaces a noun that is inhuman. Okay. For example, word pen. It was a subject. Okay. Instead of repeatedly saying pen, you could replace it with it. Okay. Let's try to identify one by one. Okay. The first one. The low speed one. What does this refer to? Is it generator, shaft, or gear? Okay, before attempting to answer, we need to go through the sentence before. Okay. There is a low speed shaft and a high speed shaft. As you can see, shaft repeated twice. I continued the sentence. Write another sentence. I said, what the writer says, the low speed one. Okay, instead of saying shaft, the writer replace it with one. So for number one, the answer is shaft. Let's see number two. I see, and it drives the generator. So the subject here is responsible for driving the generator. Okay, which one is correct? For attempting to answer, you need to go to the sentence before, because the subject is existed there, and it is work as substitute for the subject. I'll be clear. See, the high-speed shafts rotate. This shaft rotates at 1,100 and 400. I see, and it. So I'm talking about the high-speed shaft. So it's responsible for driving the generator at this speed. Okay, for three, the anemometer measures the speed of the wind. It sends this data. So which one is sending this data? Before attempting to answer, we need to go back to the sentence before. We need to identify the subject. This is the subject. Okay, this is the verb. So instead of saying again anemometer, okay, replace it with it. So the answer is anemometer. Okay, for seven, we need to complete the sentences with the correct form of the verbs in the box. So cause is used if something is the reason for something to happen. Make, to force someone to do something. Prevent, to avoid something from doing something. Okay, see the first one, the when, the place, rotate. So I don't have to here, and I don't have from. So I could not use cause, and I could also not use prevent. So the correct answer will be make. We add s because the subject is single. So we are talking about the present symbol. Okay, for number two, without understanding the meaning of the sentence, we need to go through the sentence again, thoroughly, and as we can see, we have from. The only word that I should use from with, if there is ing on the verb after from, is prevent. So number two, the controller prevents. We added s because the controller acts as singular. So we added the suffixes s at the end. Okay, for three, the blaze, the low speed two. The only word that from this list to be used with two is cause. Okay, thank you for listening. We'll finish unit 11 by going through these lessons. We talked about pistons and valves, also switches and relays, and finally we talked about rotors and turbines. We mainly use very simple tense in these lessons. We enjoy it. See you again.